Alright, Year 12. Next thing we're going to look at is oxidation of alcohols. Okay, so we need to predict the products of the oxidation of primary and secondary alcohols, and we need to talk about tertiary as well. So alcohols can be oxidized by common strong oxidizing agents. And the two that we talk about here are the permanganate ion, MnO4-, that lovely purple one, or the dichromate ion, Cr2O7 2-. Okay, we don't play around with that because it's quite toxic, but it has some nice colors here, so we're going to talk about the colors and we'll observe a video later as well. But we won't play around with it, it's a little too toxic. They also need to be in, so for these reactions to occur, a little bit of heat and also acidic conditions, so a little bit of acid in there too. So this first equation here, we've got the permanganate ion, and it's being reduced. It's an oxidizing agent, so it's being reduced to Mn2+. Okay, now we balanced it out. So if you're unsure about how to do that, go back and revise balancing redox half equations. Remember, you balance the non-oxygen hydrogens, and then you balance the oxygens by adding on water, then you balance the hydrogens by adding on H+, and then you balance the charges with electrons. But here we've got the permanganate, so it starts off purple, and when it's being reduced, it goes clear, but you do sometimes form a brown precipitate, which is manganese dioxide. With the dichromate one here, it's starting off a nice orange color, and it's going to a green color as just the chromium. So Cr2O7 2-, the dichromate, and it's going down to chromium, so which is green. So they're chosen by their color changes, okay? So when we're using them for tests, we can see a color change, which is really good to say, we've got this type of alcohol. Okay. First up, let's talk about primary alcohols. So primary alcohols, where the host carbon is only joined to one other carbon, like my example here with ethanol, just erasing that out, primary carbons are oxidized by reacting with a strong oxidizing agent, like the ones we just talked about, permanganate or dichromate, and they form initially aldehydes and then going on to carboxylic acid. Okay, so in my example here, I've got ethanol. If it's in with an oxidizing agent, it's going to go to ethanal. And if there's enough oxidizing agent, it's going to go all the way to ethanoic acid and stop. It can't be oxidized anymore. Okay, below I've just got the ball and stick model there. So notice the conditions. I've got the permanganate ion on top and a little bit of, I've got H+ representing acidic conditions, and then heat as well. Okay, so primary alcohols first get oxidized to an aldehyde and then to a carboxylic acid. Okay, so ethanol going to ethanal, going to ethanoic acid. Okay, so visually you're going to see the disappearance of the permanganate ion when you add it in to a primary alcohol, and you may see a precipitation, a brown precipitation that I've got showing here. So ethanol, adding a few drops in, you get a bit of brown precipitate, and the ethanoic acid, you get a bit more brown precipitate there. Okay. So I think here I've still got the same example, but I've changed it to the dichromate, haven't I? Still exactly the same thing going in, and I've given you the full equation down the bottom there. Okay, very difficult to get that out. Don't worry too much about it. I haven't seen that asked for before. Okay, so that interim product, so you're going from a primary alcohol to an aldehyde to a carboxylic acid. What happens when you just want the aldehyde? You want it to stop at that middle step. Okay, a couple of ways you can do it. It is quite difficult. You can think of it as a limiting reagent problem and only add enough of the oxidizing agent to take it halfway. But the trouble is you don't know what molecules it's hitting, if that makes sense. So you're not guaranteed to first convert all that alcohol over to an aldehyde. You can still get some aldehyde taking up some of that and going to a carboxylic acid and getting a whole messy mixture. Here's the best way to do it. If you want an aldehyde, what you've got to do is do a separating technique. So what you can do is a distillation setup that can be used to evaporate off the aldehyde as it forms, okay? And you can do that because the aldehyde doesn't have hydrogen bonding between its molecules. So it will have the lower boiling point, okay? Okay? It will have a lower boiling point of both the alcohol and the carboxylic acid, because alcohol and the carboxylic acid will have the conditions for hydrogen bonding. So they'll have the higher boiling point and melting point. The aldehyde will have the lowest. So you can find the temperature in between, so you're evaporating out away the aldehyde before it reacts. That's the best way to do it. Okay, secondary alcohols, or alcohols that are somewhat in the chain and not on the end of the molecule, or their host carbon, like this one down the bottom, is joined to two other carbons. Okay, secondary alcohol. They oxidize using the same reagents, and they'll form a ketone instead. Okay, as I say on here, because the oxygen was not on a terminating carbon or a carbon at the end. Okay, so also acidified permanganate or dichromate ions. So here underneath, example, I've got the oxidation of propan-2-ol. So here we've got propan-2-ol, help if I was on the pen, and we're adding permanganate acid and heat, and we're getting rid of the alcohol, and we're adding on, it's not a substitution, we're changing it to a ketone there. So it's a propanone. We don't even need to number it, do we? Because the "-one" can't be on the ends. Okay? So another way to think about it is the oxidation of primary and secondary alcohols results in the loss of carbon-hydrogen bonds and the formation of carbonyl. That's what tends to happen on that host carbon. It wants to get rid of any carbon-hydrogen bonds and form a carbonyl or a carbon-oxygen bonds. Okay? So with the primary alcohol, to go to the aldehyde, what it loses is a carbon-hydrogen bond, and it forms, well, it loses the oxygen-hydrogen bond and it forms a double bond in there, okay? So it's losing some bonds, but it's making more bonds to oxygen. And finally go to carboxylic acid, it's totally bonded to oxygen, okay? With a secondary alcohol, it's also doing the same thing. It's getting rid of the oxygen-hydrogen bond and getting rid of any carbon-hydrogen bonds and just forming with oxygen there. Now think about a tertiary alcohol, okay? If it wants to oxidize, what it's got to do is lose the oxygen-hydrogen bond and then it could form a carbonyl, okay? You can see that. The trouble is this. Suddenly, if it has to oxidize, it's got to form 1, 2, 3, 4. It's now got 5 bonds, and it can't do that. So, there's no way that a tertiary alcohol can oxidize. Tertiary alcohols will not oxidize, okay? They cannot form an extra carbon-oxygen bond because their bonds are already taken up by being carbon to carbon, okay? Primary, secondary alcohols will oxidize, tertiary alcohols will not. Okay, so this is handy. We can test what type of alcohol we have. So, if you have an alcohol that you don't know whether it's a primary, secondary, or tertiary, you can add in these coloured oxidizing agents. Say you added in the dichromate ion here. So you're adding orange to your alcohol, and if it can be oxidized, it's going to leave green. So here we've got what was propan-1-ol has now turned green. It's oxidized, okay? So if it's propan-1-ol, it's gone all the way to a carboxylic acid or propanoic acid. The propan-2-ol is now gone to propanone. It's been oxidized. 2-methyl-2-propan-2-ol, tertiary alcohol, okay? It cannot be oxidized. So it's remaining orange. The dichromate's still there. Okay? So here we can find out if an alcohol is primary or secondary or tertiary. Okay? So down below, what I've given is just the conditions for, now I've got, here's a primary actually no. I've done it the wrong way around. I should mirror this one. Okay? This one here had in, because it's still purple after being added, a tertiary alcohol. Because it hasn't reacted, it's remained purple. But here, we've got the loss of purple, and we can't really see any precipitate. So this one must have been a primary or secondary, and this one must be a tertiary. Okay. One problem that you might be saying is, well, if I can distinguish whether it was primary or secondary, or tertiary, how do I distinguish whether it was primary or secondary? Okay, I can distinguish, I can know for sure using this test if it was tertiary, but I don't know for sure if it was primary or secondary. Okay, what you can do then is you can do one little extra test that you add to it. If you had a primary or secondary alcohol and you oxidized it, you've either got a ketone or a carboxylic acid. Okay? What you can do is a test for an acid. So you can use something like pH, or, so just like indicator or something like that. One of the most common things that comes up in questions is adding a bit of a carbonate to it. Okay? An acid and a carbonate are going to produce salt water and bubbles of carbon dioxide. So adding in a carbonate, if you see bubbles being formed, you must have had the acid, so therefore you must have had the primary alcohol. Let's see how I did here. We had some unknown alcohol, we oxidized it, so we either had some turned green, which was primary or secondary, or one of our examples turned yellow, and that was our tertiary. So we knew that one for sure. Okay, but here we had one or two and we didn't know what it was. So what we did is we added in a carbonate. Okay, and what happened was the one that had the primary alcohol from the beginning showed bubbles because it was at this stage a carboxylic acid. Okay, the secondary one, the ketone, if you add in the carbonate, no reaction, nothing's going to happen. Okay. So that's a classic one that comes up in examples for these oxidation questions. Carbon, like sodium carbonate solid, was added to the mixture afterwards and it was observed that bubbles formed, or it was observed that no bubbles were formed. Okay, that's the best way that comes up in exams about finding out whether something was a primary or secondary alcohol before it got oxidized. All right, let's do a few examples. That's all the theory that we've got for our oxidation of alcohols. Draw a structural equation for the oxidation of propan-1-ol by potassium permanganate. Okay, draw out your reactant, meth eth prop. The alcohol is in the 1 position, so we've got a primary alcohol. Okay, I'm going to put all my hydrogens in there. Am I going to be lazy? Okay, by potassium permanganate. I'm just going to put the permanganate in there. The potassium is just a spectator ion. And I'm going to add heat and H+. I need acidic conditions and heat. Okay. I'm going to put my hydrogens in just to be, because you should do that in exam, shouldn't you? Terrible hydrogens in my scribble though. Okay, the backbone's not going to change. We've got a primary alcohol. So I'm going to do it stepwise. First up, what's going to happen is it's going to form a ketone. What am I talking about? It's going to form an aldehyde. Oh, what a duffer. Making mistakes when I'm recording. So it's going to form this aldehyde here, or propanal. Okay? It's going to go through another step with more permanganate and more heat and H+. And it's going to go all the way to a carboxylic acid. So draw that in the N position, because it's not going to change its host carbon. And what do we have? We have propanoic acid. Okay, so there's my structural equation for the oxidation of propan-1-ol by potassium permanganate. We're going to eventually form propanoic acid. Okay, draw the structural equation for propan-2-ol. Oh, look what I did there. Just did the positional isomer. Prop-2-ol. Draw my hydrogens in. Still by potassium permanganate. So just add in the permanganate on top. And we want acidic and heat. Okay, it's a secondary alcohol. That carbon, that host carbon there, is joined to two others, so it's a secondary. So it's going to form a ketone. Same backbone. Okay, but now we have a ketone. Fill in your hydrogens. So the propan-2-ol is going to form propanone. Ah, look at this wordy one. A mixture of three alcohols was separated by fractional distillation. So separated by their boiling points. Alcohol A had the highest boiling point. Alcohol C had the lowest, so alcohol B must be in the middle. The three alcohols were then tested with acidified potassium permanganate. Alcohols A and B decolorized the permanganate, while C did not. Each resultant product was then tested with solid calcium carbonate. The product of alcohol A reacted vigorously and produced bubbles. We need to identify A, B, C as being either primary, secondary, or tertiary. Okay, A, B, C. Let's write down what we know. Okay, A had the highest boiling point. Tiny. Okay, so tiny for C. They were tested with potassium permanganate. A and B decolorized the... So, with the permanganate, A and B decolorized. So they were either primary or secondary. So C did not. It must be the tertiary. Okay, so we've solved that one. Let's put a tick there to feel a bit of achievement. Okay. Then what they did is each resultant product that was then tested with solid calcium carbonate. The product vigorously and produced bubbles. Bubbles must mean it was an acid, so that must mean it was a carboxylic acid. So that would have been the primary alcohol. Okay. Nothing about B. So B, no. So that must have been the secondary. Okay. So there's our answer there. I've got A being the primary. I've given myself ticks here. Makes me feel good. And B is the secondary and C is the tertiary. Okay. Very wordy question. Find some format to lay it out like I did there. Okay. Oh. That's all the examples that I've got. So there's a worksheet on oxidation of alcohols. See how you go. And we've got a practical to do too. And there's some check your understanding questions from the textbook if you're still having trouble. All right, that's it for oxidation of alcohols.